Okay, let's look at these. We have magnesium reacting with cobalt. Cobalt is the ion, so the cobalt is in solution. Magnesium is more active than cobalt, so we get magnesium 2 plus because magnesium is always a 2 plus, aqueous, and cobalt solid. Here we have chromium solid trying to replace tin. It's tin 2, so we do chromium 2. Chromium 2 plus tin because chromium is more active than tin. Here we have barium solid plus tin 2 nitrate. Barium's more active than tin, so we get barium nitrate and tin solid. And the last one, copper and HBr, hydrobromic acid, we get no reaction because copper is not more active than hydrogen. Copper cannot replace hydrogen. So I think those are pretty straightforward. Look at the chart, and the important thing is just remember to write the proper formulas and then balance the equation. Now, do you have any questions so far? Okay, this next activity, this information is in Chapter 18 in this textbook. In other textbooks, it's in Chapter 4 or 5 at the very beginning of the semester with the introduction to redox. And I think it makes sense to put it with the introduction to redox, so I've rearranged the book. Plus, here at Delta, it's in our objectives for Chem 111. So we're going to talk about how to balance these redox equations because redox equations are often written as ionic equations, and when you look at them, you cannot balance them easily by inspection. You have to really work at balancing these things. So we have this method, the ion-electron method, because we have ions and because we use electrons. So when you look at these, there are going to be two situations. Things that are in acidic solution, meaning they have free hydrogen ions, and things in basic solution where there's lots of free hydroxide. So we have a series of steps, and this makes absolutely no sense when you first look at it until you do an example. So we write the unbalanced equation. We divide it in two half reactions. One half is oxidation, one is reduction. We balance each half with regard to anything except hydrogen and oxygen by inspection. Then we add water to the side that needs oxygen because water contains oxygen. We add hydrogen ions to the side that needs hydrogen. We add electrons to the more positive side. We make the number of electrons the same in both halves, and then we add them together and cancel out everything that appears on both sides. And that makes no sense when you first look at it, so we really have to go through an example so you can understand this.